Hello everyone. In my last class, I have already discussed about realization of one flip-flop using another flip-flop. In my last class, I have discussed about realization of a D flip-flop using an SR flip-flop and realization of a JK flip-flop using an SR flip-flop. So today I am going to discuss about the realization of delay flip-flop or D flip-flop using JK flip-flop. So the procedure is same for all the flip-flops. So as we are going to realize D flip-flop using JK flip-flop, so first the D input will be fed to a next state decoder or a combinational circuit. Now the output of the combinational circuit or the next state decoder will be fed as the J and K inputs of the JK flip-flop. The Q and Q bar, they will be fed back to the input side of next state decoder. So this is the basic block diagram of a delay flip-flop using a JK flip-flop. Now coming to the procedure. Step 1 is we have to know about the operation of D flip-flop. That is already known to all of you. So I am not going to discuss it again. Now coming to step 2. In step 2, first we have to draw the present state next state table for a D flip-flop. So this is the PS-NS table of D flip-flop. Qn is the present state output. Qn plus 1 is the next state output. So when the present state output is 0, D is 0, then the next state output will also be 0. As in case of D flip-flop, as you all know that the next state output follows the D input. So this is same for all the other three cases. Second case, the present state output is 0. We are giving D as 1. So we will get the next state output as 1. The third case also, present state output is 1, D is 0. So the next state output will also be 0. In the fourth case, present state output is 1, D is 1. So the next state output will also be 1. Okay, now coming to the step 3. Step 3 is the in step 3 we have to append this excitation table of JK flip-flop into this present state next state table of D flip-flop. So first coming to excitation table of JK flip-flop. So you already know about it. So I am not explaining it now. This is Qn. Qn means present state output. Qn plus 1 means next state output. J and K, they are inputs to the JK flip-flop. So this is the excitation table of JK flip-flop. Now what we have to do, that is we have to append the values of J and K to this present state next state table of D flip-flop. You can see this table here. The first 3 columns, it consists of the present state next state table of D flip-flop, and the 4th and 5th column, they are J and K inputs respectively. So how to form this table? Qn is 0, D is 0, Qn plus 1 is 0. Now from the excitation table of JK flip-flop, we have to find out the values of J and K for the condition where the value of Qn is 0, Qn plus 1 is 0. So coming to the excitation table of JK flip-flop, when Qn is 0, Qn plus 1 is 0, then the values of J and K are 0 and D respectively. So here in the first row, we are writing 0 under J and D under K. Now in the second case, Qn is 0, Qn plus 1 is 1 and the value of D is 1. So again we have to find out the values of J and K when the value of Qn is 0, Qn plus 1 is 1. Now coming to the excitation table of JK flip-flop, when Qn is 0, Qn plus 1 is 1. Then the value of J is 1, value of K is D. So we are writing here the value of J as 1, value of K as D. Similarly, in the third case, we can also write down the value of J and K. Like when Qn is 1, Qn plus 1 is 0. Then from the excitation table, we can find out the values of J and K. When Qn is 1, Qn plus 1 is 0, value of J is D, value of K is 1. So we are writing here the value of J as D, value of K as 1. Similarly is the last case. In last case, for Qn equal to 1, D equal to 1, Qn plus 1 equal to 1, we are getting the value of J as D, value of K as 0. Now coming to step number 4. In step number 4, we have to design the next state decoder or the combinational circuit. Or we have to find out this simplified expression for J and K in terms of D and Qn. So we have to use K-map to find out this simplified expression of J and K. So you can see here there are two K-maps. So the first K-map is to find out the expression of J and the second K-map is to find out the expression of K. So coming to the first K-map. It is Qn, it is D. So when Qn is 0, D is 0, then what will be the value of J from this table? When Qn is 0, D is 0, then the value of J is also 0. So we can write here 0. Next, the value of Qn is 0, value of D is 1. What will be the value of J? Value of Qn is 0, value of D is 1. And the value of J is 1 here. So we have written 1 here. Now we have to find out J for Qn equal to 1, D equal to 0. So Qn equal to 1, D equal to 0. The value of J is D. So here we are writing the value of J as D. Next, Qn equal to 1, D equal to 1. Then what will be the value of J? Qn 1, D 1, J will be D. So we are writing here D. Now we can form a group including this 1 and this D. Like this we can form a group. So what will be the value of J? The value of J will be D because the value of D is 1 here. So J equal to D. This is the simplified expression of J. Now coming to the second K map. It is to find out the expression of K. Now following the same procedure, this is Qn, this is D. So when Qn is 0, D is 0. What will be the value of K? Qn 0, D 0, value of K is D. So we have written D here. Next, Qn is 0, D is 1. What is the value of K? Qn is 0, D is 1, K is D. So we have written D. Next, Qn 1, D 0. Qn 1, D 0, K is 1. So this is 1 here. Next, both are 1. Qn is 1, D is 1, K is 0. So we have written 0 here. Now we can form a group like this, including this D and this 1. Here the value of D is 0. So we can write K equal to D bar. Now we have the expression of J and K with us. Now what will be the next state decoder or the combinational circuit? Here we can see that we have to use one NOT gate here because K equal to D bar, only one NOT gate is required. So in the design of combinational circuit or next state decoder, we will use a NOT gate only. Now coming to step 5. In step 5, you can see this is a NOT gate and this part consisting of this NOT gate, it is the next state decoder part. As J equal to D, so this D input will be directly fed to the J input of JK flip-flop. And as K equal to D bar, so this D will be fed to this NOT gate and the output of the NOT gate, that is D bar, will be fed as the K input of this JK flip-flop. This Q is the output of the JK flip-flop, Q bar is the complemented output of the JK flip-flop. And this, when we design this whole circuit, then the output of the JK flip-flop, that is Q and Q bar, that will be changed according to the input values of D. That means this whole thing will behave as a D flip-flop. As because whatever input values we give to this D input, we will get our output according to that D input value. So this is a D flip-flop constructed by using a JK flip-flop. Thank you.